So, hello students, let us start the next chapter, chemical kinetics. And what is the introduction of chemical kinetics given by NCERT? That the chemical kinetics help us to understand how chemical reactions occur. This is the quotation on in the NCERT book. How the chemical reaction occur. Okay. We'll take some more example to define what is the meaning of this chemical kinetics word and to introduce the many of the things given here. But before that, let first know about what is the need of chemical kinetics in the chemistry. Even this is the one of the branch of physical chemistry as well, chemical kinetics. For any chemical process, the thing which is required is the three things. The one is there is any feasibility of chemical reaction or not? Means the chemical reaction will occur or not occur. The second thing is what in which extent the chemical reaction can go forward. Is there is any possibility to backward the reaction or reverse the reaction at the same situation? That is the possibility of equilibrium or reversibility of the possible reaction. And the third thing which is most important to know about the chemical features, the chemical behavior of the process, that is at which rate the chemical reaction will occur. Always the chemist and physicist try to find out the different scenario about any chemical or physical process, how these three things can be defined. Because without knowing the chemical reaction will occur or not, we cannot define about the chemical reaction, the means of product, the reactants that can be go in the product. Without knowing the at what extent the reaction go forward and what extent the reaction come far backward, we will not define the reversibility possibility and the majority of the production of the any product. And the third is, which is really a most important, we have to be ensure the rate, the speed of the forward as well as backward reaction. Because without knowing the speed of the reaction, we cannot define the efficiency of the product, the efficiency of the chemical process. Many of the examples and other things given in the NCERT to learn to define these things. Chemical kinetics is the chapter which belongs to the how to determine, how to learn the rate of the chemistry, the rate of the chemical reactions and its mechanism. All those factors which can affect the rate of chemical reactions and the mechanism of chemical reaction can be understood in this chapter, in this branch of the physical chemistry. Chemical kinetics. So before going to the next topic, that is the very first topic about the rate of the reaction, first let introduce what are the things given in the NCERT, and for that let's discuss about some of the examples given in the NCERT book. Thermodynamic data indicate that diamond shall convert to graphite, but in reality the conversion rate is so slow that the change is not perceptible at all. Students, according to the thermodynamic data, it can be observed that the diamond can be converted into graphite, but practically it is not possible. Practically it is not possible the conversion of diamond into graphite, because the rate of conversion of diamond into graphite is so quite slow. So practically it will not be possible of the conversion of diamond into graphite. That is the one of the very benefit of the knowing of the rate of the reaction. The second thing which is given here, I think, I'm not getting where is the given book, but we can explain. The second thing, suppose we are going for any dentist to fill the some materials in the cavity, some cavity occur, and the filling of the materials that filled in the cavity must be chemically stable at the instant time. Without knowing the chemical composition and the rate of the solidification of that material in the cavity, we cannot use that as things which can be filled in the cavities of the teeth. Because we are knowing the rate is very important now, because as we fill the materials in the cavity, the filling materials in the cavity of the teeth, it must be solidified instantly, so we can use as a regular teeth. The same time, many of the other materials which are used during the during the different categories in environment, we have to be ensure at which rate the chemical process occur inside that body, inside that process. Without knowing the actual rate of performance of the reactants that will give you a product, we are not able to explain, we are not able to use that materials for any other purpose or any other process. The practical use of any material, any substance is actually depend upon at which rate the conversion takes place. Okay, it is fine. First we have to be know, first we have to be sure the things will be go on or not. That is called the feasibility or spontaneity. That can be explained on the basis of thermodynamics. But the same thermodynamics cannot be applicable without knowing the rate of this, the rate of the process or rate of this reaction. So this chapter is all about the rate of the process, the rate of the reaction. The first topic which can be we have to learn, that is the rate of chemical reaction. Let's discuss about the rate of the chemical reaction. I think you remember about to knowing about any kind of rate of reaction, to knowing about any kind of rate of any process, we must be apply at which time, at which conception of passing of time the process occur. The rate always indicated the per unit time. Here we are discussing about the rate of reaction. The rate of reaction, that might be a first topic, huh? The rate of reaction, students, for any given reaction, suppose I'm just taking a general reaction, R stand for reactants and P stand for product. At the very beginning, when we just taken the reactants at a given certain time interval and for a given medium and concentration, with the passage of time, the concentration of reactants consumed means decreases, and the same passage of time interval, the concentration of product increases. Means the rate of the reaction for any different time interval, we can actually define on the basis of disappearance of concentration of reactants per unit time, or we can explain on the basis of appearance of the concentration of product per unit time. Suppose we have two different times. At T1, the concentration of reactants suppose is R1 and the concentration of product is suppose P1. At time T, at time T2, it will become the R2 and P2. You have to know about with the passage of time, the concentration of reactants must be decreased, so R2 is smaller than R1, and with the passage of time the concentration of product will increase, means the P2 will be greater than P1. The square bracket actually indicating the molar concentration of the any given things or reactants or product. The molar concentration. The square bracket. You should learn that. Always, whenever the materials or the things are enclosed in the square bracket, in chemistry, it is indicated the molar concentration. The concentration of the material that actually takes part in the chemical reaction is called molar concentration. That is called molar concentration, and unit should be a mole per liter. Generally, mole per liter for any type of the reactants or product. For gaseous species, it can also be in the atmosphere in the terms of pressure or bar. Okay, in the standard condition. We will write the unit of the after this equation. Okay. So with the passage of time, now we can define that. The rate can be the consumption of reactants per unit type. That means delta R upon delta T. That delta R indicating here R2 minus R1 and delta T indicating here T2 minus T1. But we are knowing that the difference of R2 minus R1 will be negative because R2 is smaller than R1. So we have to be put here the negative sign that will make the balance of positivity of the rate of the reaction. The same time we can define as rate of the reaction in the terms of product, that be plus delta P upon delta T. Students, the appearance of the product actually must be equal to the appearance of reactants, because what amount of reactants will consume, the same amount of the product can be formed in the ratio. The ratio are same. You can see that here the stoichiometric coefficients are similar for reactants and product, so the consumption of amount of reactants will equal to the appearance of the amount of product. So both this equation can be equate to each other. So we can write like this: rate equal to minus delta R by delta T equal to delta P upon delta T. This will be an average rate of reaction. We are talking about the average rate of reaction because there is a large difference of the concentration of reactants and the large difference of the concentration of product. We are using delta, so this will be called average rate of reaction. Average rate of reaction, you can see that. Okay, so you can put here average. Okay, the same time you can draw the graph of the average rate of reaction. I am putting graph here. At the particular time, here will be the concentration. In the terms of reactants, the concentration will decrease with the passage of time. So the slope of the graph will come downward. First thing, the slope will not be a regular straight line because the concentration of the reactants that decreases with the passage of time will not be uniform. At the very starting when the reaction begins, the consumption will be fast. As the passage of time takes place, the consumption of reactants will be also slow down. So there will be a non-uniformity and we can actually get a curve. we can get a curve that actually indicates the consumption of reactants. For any 2 points, you can just take out the difference of the reactants. Suppose for this time and for this time, so you can see that with the help of graph, you can calculate the rate of the any reaction. That will be T1, T2, and that will be R1, R2. So we can get the value R1, R2. So here will be average rate equal to the slope will be difference of the product reactants upon difference of the time in the minus sign. Delta R okay. So the negative slope indicating the average rate of reaction for any given data of any given reaction, where you can see with the help of graph you can calculate the difference of the reactants consumption and the time passes, and with the help of that you can calculate the value of average rate of reaction. The same time you are knowing about in the chemical kinetics or any time when the difference of the passage of time is very infinite small, means delta t approaching 0, that is called at instant. If we want to calculate the rate of reaction, that is called instantaneous rate of reaction. Instantaneous rate of reaction, that actually indicating for any given instant what will be the rate of reaction, that will be actually depend upon a very small difference of the reactants and the any given instant of the time, where the difference, the large difference become a 0 or near to the 0 actually. Okay, for that we have to be draw a slope on the graph, and it is called instantaneous rate of reaction, that will depend upon minus d r upon dt. Delta t limit to 0, it's indicating the differential points, the differential actually rate of reaction, the instantaneous rate of reaction. Always the tangent, the point of tangent which touch with the slope, indicating the instantaneous rate of reaction for any given type of reaction. So we have two different types of reaction now, the average rate of reaction in the terms of reactants and instantaneous rate of reaction in the terms of reactants. The same graph can be plotted in the terms of product. Even we are knowing for product the concentration increases, so the graph will be different. The graph will be different. The graph will be different. You can see that this graph indicating at the very early stage the production of product will be very large, but as with the passage of time, the production also decreases. That will give a non-uniform production of the product, and that's why there will be a curve that's indicating. Students, you can calculate the average rate of reaction in the terms of product with this graph, and here will be R average equal to delta P upon delta T. The same time you can calculate the instantaneous rate of reaction in the terms of product also. So with the help of tangent, draw on the slope of the product and time graph, you can calculate the instantaneous rate of reaction in the terms of product, instantaneous rate of reaction in the terms of reactants. So these two different graph actually explaining about how and at which rate the consumption or the disappearance of reactants takes place with the passage of time. At the same time, at which rate the appearance of the production of the product can be takes place with the passage of time, and we can calculate with the help of large difference or the small difference, that is called delta T limit to 0. Okay, here the slope will be positive, you can see, and here the slope will be negative. Minus slope in the terms of reactants indicating the reactants decreases, the reactants consumed per unit time called average rate of reaction. Now the problem is it possible to consume the reactants and product with the same rate or not? That can be explained on the basis of different example what we can use here. But before that, first let's discuss about the unit of reaction. You can see the unit. The unit of molar concentration is, as I told here, mole per liter. So unit will be the concentration time inverse. The concentration time inverse, okay? If the concentration indicating the mole per liter and time is denoted in the second, then the average rate of reaction or instantaneous rate of reaction for both, the unit will be mole per liter per second. And in the terms of pressure, the same unit can be defined in the terms of pressure time inverse. Pressure time inverse, and for that the value will be the unit will be in the terms of pressure. If the gaseous species are used and gaseous species are given in the terms of partial pressure, then the unit of the average rate of reaction or instantaneous rate of reaction will be atmosphere second inverse, or in the terms of bar second inverse. As we are knowing, the atmosphere value is nearly equal to the bar value. 1 bar equal to nearly 0.987 atmosphere. So this can be equated together. This will be unit. This will be unit. Okay. Now we can discuss about how this consumption takes place with the same rate. Because here I am equating the value that disappearance of reactants per unit time is equal to the appearance of product per unit time. But is it possible to equate these two values for all different types of reactions or not? Let's discuss about. These two values are equated here on the basis of there are stoichiometric coefficients are same for reactants and product. But what will happen for the different types of reaction? Let's discuss about. Look at this reaction. Look at this reaction. what you can see that? What you can see? You can see that the 2 mole of hydrogen iodide when consumed, there will be production of 1 mole of hydrogen and 1 mole of iodine. It means the consumption of hydrogen iodide is a double in the rate of the production of hydrogen or iodine. Because the 2 mole consumed in the same time, and the same time there is production of 1 mole of hydrogen or 1 mole of iodine. So 1 mole of production of these two, indicating the consumption of 2 mole. So the rate of this HI must be twice the rate of the production of hydrogen or the rate of production of iodine. To equate the reactants in the terms of product, for this formula, this value must be divided by 2. This value must be divided by 2 means the rate of the reaction. For this reaction, we can write like this. Look at the possibility. Look at the possibility. Here you can see that the average rate of reaction for this given reaction is minus 1 by 2 delta Hi upon delta T equal to delta H2 upon delta T equal to delta I2 upon delta T. Here I just putting the value 1 by 2. What information you can draw from this given statement? You should draw the information is, if the stoichiometric coefficients are present, it must be invert, it must be reciprocal to define the rate of reaction together in the terms of reactants and the terms of product. And that is why during the writing of the average rate of reaction for any general equation, we are generally using for this reaction. See, the average rate of reaction will be look at the possibility. For any general reaction, if the reactions are like AA, BB equal to CCDD, indicating some stoichiometric coefficients given, so the coefficient must be in a inverted position, reciprocal position with a different sign. For reactants, there will be a negative sign, and for product, there will be a positive sign. The very important thing is, the rate of any reaction can be defined in the basis of any other reactants or any other product, and all reactants and products can be equal if the stoichiometric coefficients are inverted in the ratio. So you can see the rate of the reaction for this given reaction is minus 1 by E delta A upon delta T equal to minus 1 by V delta T equal to plus 1 by C delta C by delta T equal to plus 1 by D delta D by delta T. So you can calculate the rate of reaction, the average rate of reaction in the terms of any one of the reactants, either A or B, or in the terms of any one of the product, either B or either C or either D. There is only difference, coefficient given must be in a reciprocal. Coefficient given must be in a reciprocal. So you can calculate the rate of reaction in the terms of average or differential. But the instantaneous rate of reaction can be calculated by the some integral value that will be discussed later in the section, the upcoming section. Here only, first we have to be deal with the average rate of reaction first, because for the instantaneous we have some different segment. We will deal the different topic, the different equation for the instantaneous rate of reaction. Okay. Here first try to calculate the average rate of reaction and some of the questions given in there also. So students, this is all about the first topic of this chapter, where we'll try to find out some of the conceptual knowledge about average rate of reaction, consumption of the reactants, and the appearance or the production of the product. How can we calculate the average rate of reaction? Means average rate of the consumption or average rate of the production. Based on this topic, there are some questions given in the NCERT. You can go through that question and we can discuss the next the questions in the next lecture. Okay, this is all about the first lecture. Try to complete your different topics related to this lecture, and if there is any doubt, you can ask me directly. Okay, we'll deal the next topics in the next lecture. Thank you.